was able to process 20,000 images from the National Gallery of Art's image archive without spinning up a single server. Using MixPeak's built-in feature extractors, which scale up on demand, we were able to run the state-of-the-art image embedding model from Google, SigLIP, in order to convert 20,000 images into embeddings in under an hour. So let's walk through how we did it. So in the MixPeak studio, we have a namespace, and within the namespace, we have feature extractors. The feature extractor that I'm using for this image gallery demonstration is the Google SigLIP 768 dimension embedding model. So if we take a look at this, we can see in Hugging Face, we have a bunch of open source models. This is the model that we'll be using. And as we can see, we have some starter code as well as a sample data set that we can use in order to generate embeddings. So this is the transformer model that we're using under the hood when we actually generate embeddings using the image extractor built-in feature extractor. And so this is the namespace that we are using. So as we can see here, the image galleries namespace is what we'll be using throughout the entire studio experience for this use case. Feature extractors are scoped in namespaces. Namespaces are effectively clusters of databases, compute, etc., all within one single experience. And so then what we do is we create a bucket, and that bucket effectively has all of the data that we'll be using to upload objects in order to do the processing. And so in this case, this bucket schema has an image and a bunch of metadata. So we can see none of them are required. So then what we can do is we can upload any kind of object. It can contain some of these keys. It can contain all of these keys. And then if we scroll down a bit, we can see the actual processing flow that happens once we upload the object and submit the object for processing. So as we can see, we've got the bucket called Portrait Gallery. Again, this is where we're uploading the images. And then we've got the gallery collection. And so the collection is where we're actually instantiating the feature extractor that runs the Google SigLIP feature extractor, image embedding model, right? So in this case, 768 dimensions. And as we can see, what we did is we created a batch of 120,000 images, objects, and we processed them in one go. And as we could see, it took just a couple of hours. So it was really nice to see processing it and then waiting a couple hours, grabbing a dinner, and then it being finished when we get back to the studio. So as you can see, it was completed. And so let's take a look at what that actually looks like. We have a bunch of documents in this collection. Again, this is where the bucket transmitted the output of the feature extractor that we selected for this namespace, for this image gallery's namespace. And so in this case, we got a bunch of documents. Some of them have thumbnails that were generated. Those thumbnails are contained in the CDN. So a CDN is a delivery network that gets cached locally to wherever the client is, so it's fast. And so we have, in this case, we've got a bunch of those metadata keys from the National Gallery of Art archive. And if we scroll down a bit, we see the actual embedding. Now, this is important because the embedding is what we use for search when we do reverse search, query search, image search, etc. And as you can see, it's called image extractor v1 embedding. And this is important, again, because we don't want to actually figure out, hey, which embedding model do we use? Which dimension do we use? Which weights do we use? Which frozen state of the model? None of that matters. All that matters is we selected a namespace. Within the namespace, we have the feature extractors. Within the feature extractors, we have an image embedding model that was used. And so as we can see, we have a feature URI that is what we are using whenever we do retrieval under the hood. And so we have two retrievers that are actually scoped or configured to this collection. Let's take a look at them now. So we have this retriever stage. And this retriever stage at its core is really just three substages within a single feature search, right? So again, we have the feature URI. The feature URI is the abstraction. It gets resolved to the inference endpoint, the image embedding, the actual collection, the version of the feature extractor. So all of these are collapsed into this single string. And so this allows us to say, hey, we want to use this feature extractor today and this feature extractor tomorrow. How do we compare the results? Well, the results are just compared by swapping the feature URI. And so that is a very elegant way of handling A/B testing, embedding model evolution, re-embedding, etc. And so in this case, we have three different feature URIs, three different feature searches that are within the same search execution. And so in this case, it's using Reciprocal Rank Fusion, which is just a hybrid search across all three of these. And so it's saying, hey, when I supply a text query, generate an embedding using this feature URI, and then use that for the KNN feature search. If I supply an image, do the same thing. If I supply a document reference, do the same thing. Or if I supply all three of them together, combine them all into a Reciprocal Rank Fusion operation. There's a ton of different strategies for combining different feature searches in the same operation. But as we can see, reciprocal rank fusion is typically the most standard, but we have others like weighted, learned, if we want to actually have the search evolve as our users interact with the system. And we actually have everything that I'm talking about here in this single blog post. If you go into the mixedpeak.com blog and then click multimodal image search with SigLIP and RRF, you can see an actual demonstration of the app that we've built using the image extractor. And so as you can see, you can click a document, you can get the similar documents, you can do a text search, people dancing, find people dancing. You can combine people dancing with document searches, right? And so this is what we were talking about when we said these are the different types of queries that all go into the same feature search, and then they're merged via reciprocal rank fusion. So that's hybrid search. And so as you can see, we have in this blog post, we have a breakdown of all of the different components that were involved in actually building this. With the API, with the queue, we have the distributed compute inference endpoint, we have the vector databases, we have the GPUs that auto-scale based off of demand, right? And so in this case, we actually were able to process 60 milliseconds, for every image, it took 60 milliseconds. So that was quite impressive of an operation, and we fully saturated the GPUs under the hood. And so going back to the actual retriever, we have the stages. The retriever stages are then what we use whenever we want to execute the retriever. We supply these inputs, text, image, document, reference. So going back to the demo that we showed, those are the different inputs that we supplied when we have this UI. So this is, again, a demo application. When we click the magnifying glass, it's doing the document reference. When we click when we type in a text query, it's doing a text to image query. When we upload an image to do the query, it's doing the image-based query. And it's combining them all in, again, a reciprocal rank fusion operation. So we have a bunch of demos here, or a bunch of links that we could use. If you go to the MixedPeak GitHub showcase, you could see the actual code that we use in order to download the National Gallery of Art images, all 120,000, as well as ingesting them into the MixedPeak bucket and then processing using the image extractor. And so again, everything that we're doing under the hood, it's open source, nothing fancy, but really what we're optimizing for is you never have to think about servers, you never have to think about embedding models, you never have to think about the evolution of your index, and you never have to think about search, because we have collapsed all of the retrieval operations in a combination of different types of stages for a single retriever pipeline. And we have all of the retriever stages available in the documentation. As you can see, they're combinations of filtering, sorting, reduction, application, and then ultimately you get the outputs, the documents that you want. So you can enrich using third-party data, you can sort, you can reduce, filter. Again, all of this as a single API call for your application, for your agent, for your humans. Again, my name is Ethan. You could see the demo of this application if you go to the blog post here. Let's see, the actual blog post. You could see the actual demo of the application, mxp.co/r/npg, National Portrait Gallery. I think we changed the name. It's actually National Gallery of Art, NGA. But again, my name is Ethan. I'm excited to see what you build with this.